Okay, so we're going to work through a couple of examples out of your big booklet. So these are all on the Alkane sheet. Okay, so these are going to talk about some of those extra rules that we kind of skipped in that last video. So where those extra rules come into play is when we have more than one side chain, right? So the example that we did in that last set of notes only had one side chain, which makes it really easy when I'm trying to put my prefix together because there's only one thing that needs to go into the prefix. But when you have a look at a molecule like this, it has a whole bunch of things sticking out of it. So that means there's a whole bunch of things that need to go into that prefix. So when I want to put things into the prefix and I have more than one thing, you'll notice that they need to go in alphabetical order, okay? And that's something that's consistent when we're in organic, that if we have more than one thing that needs to go either into the prefix section or into the suffix section, we're always going to put them in alphabetical order, okay? So when we look at this one, it says, why is the name 2-ethyl 2,4-dimethylhexane unsuitable for the following compound? And what is the correct name of the compound? So when you first look at it, you might be like, well, that name seems pretty good to me, right? I've got my root right here, which is hex, which means 6. And I go 1, 2, 3, 4, 5, 6. So that sounds fine. Ane is good. Ane is good because all I see are single bonds. I don't have anything else. And then it's like 2-ethyl. Okay, well, 1, 2. Here's an ethyl. That seems good. And then we have a 2,4-dimethyl. So why is it called dimethyl? Well, it's called dimethyl because this guy and this guy are both methyls, right? And they're both methyls because they each have one carbon. Why we call it a dimethyl? Well, we're not going to write the name methyl twice. We're just going to group them together and call it a dimethyl. And if we had 3 of them, we would group them together and we would call them a trimethyl, okay? So other thing you'll notice in this name is we now have some commas, right? So we talked about dashes. We talked about using dashes to separate a number from a letter, but we didn't really talk about a comma. And that's because we didn't have that in the example we were looking at. So why we use a comma? We use a comma to separate numbers from numbers, okay? So in this case, we have a 2,4-dimethyl. That's telling us that at carbon number 2, we have a methyl. And at carbon number 4, we have another methyl. So really, when you look at this name, you might be like, well, everything about it seems fine. It tells me everything. But I'll tell you what the problem is. They chose the longest chain to be this. If you look at this molecule, that is not the longest chain, right? We like to think, oh, the longest chain always has to go straight across the page, but it doesn't. If we look right here, we can make more than 6 carbons, right? 1, 2, 3, 4, 5, 6, 7. We have 7. Okay, 7 is more than 6. And that's why that name isn't right. It doesn't have the right longest chain, okay? So, easy part to this name is figuring out the root, right? If we have 7, then we know the name for our root should be hept, right? Because hept is what goes with 7. Suffix is also nice and easy. This is an alkane. I know this is an alkane because everything is a single bond. So I know it's a heptane, okay? Where the complicated part comes in is my prefix, right? So when we look at this molecule, we have 3 side chains, right? Here's one, here's the second, and here's the third. Okay, they're separate because they're not all grouped together. But they do have some commonality to them, right? And what's common for them is that they're all methyl groups, right? And they're all methyl groups because they have one carbon in them. Okay, remember il, because it's a side chain, and methyl. So if I have 3 of them, remember we talked about how we would group them together? This is going to be a trimethyl. Okay, that's telling me that I have 3 methyls. So when we start to add that into our prefix over here, we're going to have trimethyl. But the other thing we need is because we're saying trimethyl, we're saying that there's 3 here. We need to put 3 numbers in front of it, okay? One number telling me where this one is, another number telling me this one is, and another one telling me where this one is, okay? Even if some of the numbers are the same, I'm still going to have three numbers. Okay, so when you have more than one sidechain, this is where your numbering gets a little messy, okay? Remember we said we wanted to have the lowest number possible? Well, what I need to do is I need to check from both options what numbers I get, right? So if I start numbering down here, right, this would be 1, this would be 2, this would be 3, here we'd have 4, it's an awful 4, let's try to fix that up, there we go, we have 4, here we have 5, here we have 6, here we have 7, right? So when we look at that, this guy here would be at number 3, this one would also be at number 3, right? They're separate because they're not grouped together, but they are both attached to number 3. And this one would be at 5. So my numbers would be a 3, and a 5. But now we need to check if we numbered the other way, right? So if I went the other way, this would be carbon 1, this would be 2, this would be 3, this would still be 4, this would be 5, this would be 6, and this would be 7. Okay, so now what we need to do is we need to decide which way gives me the lowest number, okay? So 1, 2, 3, here we have something happening at number 3. 1, 2, 3, uh-oh, they're both at number 3. What are we gonna do? If they were different numbers, so like this was at 3 and this was at 4, easy peasy, 3 is smaller than 4, we would choose to number using our black numbers, okay? But in this case, there are 3 and a 3, so this is what we call a tie. So in the case of a tie, just like any time there's a tie, you gotta go to a tiebreaker. So first rule of a tiebreaker is alphabetically sidechain names. So if this was a methyl, and let's say the other one was an ethyl, E comes before M, I would give the E, or the ethyl, the smaller number, right? It would win the 3. But in this case, they're both methyls. So going to an alphabetical tie break doesn't really help me because I'm still in a tie break. Okay, so in this case, because everything is a methyl, we kind of have to look at what the numbers are, right? So if we use the black set of numbers, we're going to have a 3, another 3, and a 5, right? Because 3, 3, 5. If we use the blue numbers, we have 1 at 3 and 2 at 5, right? So overall, in this case, we're looking for the smallest set of numbers. So we have a 3, and a 5, or a 3, a 5, and a 5. So over here, because this is a 3, right, that's really the only difference between the two, a 3 is less than a 5. So we are going to choose the black numbers, okay? So how this is going to look then. So we are going to have 3, 3, 5, right? And that's because those are our numbers and we need to separate numbers from numbers using commas. Then dash trimethyl. Okay, so that's the right name for this compound. It's a 3,3,5 trimethyl heptane. Okay, so let's look at some other examples. Okay, so this is number 5 in your booklet. Okay, so kind of always following the same pattern of trying to figure out where is my longest chain, right? So check across the page, 1, 2, 3, 4, 5. Let's check some other options. If I start up here, 1, 2, 3, 4, 5, still the same. What if we go 1, 2, 3, 4, 5? That's also the same. If we go 1, 2, 3, 4, 5, that's also 5, but I don't want to pick that because then I get this weird branching thing and we never want to have that. So any of those other options are going to work. Let's go straight across the page because that's a bit easier. Okay, so we have 1, 2, 3, 4, 5 carbons because we have 5 carbons. The name for our root is going to be pent. Okay, everything in this is a single bond, so it's a pentane. Now we need to talk about this guy and this guy over here. So this one has only 1 carbon in it. so that means it's a meth. Okay, one carbon is meth. It's going to end with YL, so it's a methyl. Then we've got this guy over here. When we look at this, it has 2 carbons. So because of 2 carbons, it's an ethyl. Okay, well, that was a really big E. And then il. Okay, we got a number. So I always want smallest number. I only go to a tie break if they're the same. So if we start numbering at the left side, this is 1, this is 2. So I have something at 2. We start numbering from the right side, 1, 2, 3. So a 2 or a 3, which one's smaller? A 2 is. So that means we're going to number 1, 2, 3, 4, and 5. Okay, when we go to put that together in the name, we now have a methyl and an ethyl that need to go into here. So they're going to go in alphabetical order. So the ethyl alphabetically comes before methyl. So it doesn't matter about numerical order. It matters about alphabetical order. So because that ethyl was at carbon 3, we're going to go 3-ethyl. Okay, then we need to put in that 2-methyl. So again, because we're going to put a number, we need to put -2-methyl. Okay, then right into the pentane. So a 3-ethyl, a 2-methyl pentane. Okay, in the name, alphabetical order. So let's look at 1. Here we go in the opposite direction. So now we have a name, and we're trying to actually come up with our diagram. So I want to start by figuring out where's the root of my name. It's hept. Okay, I want to think about what does hept mean? Well, hept means I have 7 carbons, right? So 1, 2, 3, 4, 5, 6, 7. Okay. I put everything as a single bond. I did that because the ending was "ane." Okay. So when you are drawing, always put them straight across the page. Don't bend them. Don't do anything complicated. Try to keep it simple. The other thing when you're doing it, always number from the left side. And the reason I want you to do that is if you decide to number from the right side, chances are you're going to forget halfway through the question that you did that, and then you're going to start from the other side, and then you're going to mess your molecule up. Okay, so it's a 2,4-dimethyl. So that's telling me that carbon 2, so here's carbon 1, here's carbon 2. That means down here, I need to have another carbon. So put a line in, here's our other carbon. Only 1 because it was a meth, right? And meth means 1. Okay, then we also know that at carbon 4, we need another one. So 1, 2, 3, 4, put another one. Okay, that takes care of all our carbons. Now all we need to do is fill our H's in. Okay, we talked about how carbon always wants to have 4 bonds. So we look at this. So this carbon here has 1 thing attached to it. To get to 4, it needs 3 more. So either you can draw your 3 hydrogens kind of like this, or if you want, you can do that condensed structural and write H3 next to it, kind of whatever you want to do, it doesn't matter. Okay, then we move to this carbon. So it already has 1, 2, 3 things attached to it. So that means it only has room for 1 more hydrogen, right? That fills it up. Okay, and then just keep going, right? This has 2 things attached. We need to fill it up. It gets 2 more. Okay, then keep going, right? I'm going to switch now just to show you what it would look like if we did it the other way. Right, so if I was doing a condensed structure, I'll put 1 H there, that now gets it to 4. We look at this carbon, it has 2 things attached to it. So either I could do an H above and below, or I could just do H2 next to it. Same deal with this one, because it already has 2 things. And then this guy here needs 3 to get it to 4. Okay, then we go back to these other ones. We don't want to forget about those that are part of our side chain. This guy needs 3 because it only had 1. And same with this one. Okay, so find the root, do your longest chain, number from the left side, and start to throw in those side chains.